Okay, so the first two problems here are the same concept. We're looking for the average between two values of x for the function y. Okay, so the first one, question one, the number of daily sales of a product was found to be given by sales equal 700 x times e to the negative x squared plus 700. And this is, again, this is the daily sales. And we want to find the average of sales during the first 60 days of the campaign. That is from x equals 0 to x equals 60. Okay, so since this is business calculus, I'm going to assume that we're going to be using the integral definition of an average. So the average value of a function should be the integral from a to b of that function times a dx divided by b minus a. Another way that you could think of this is, since the integral is a sum, we're summing up all the daily sales, and then we're dividing by the number of days. So it is analogous to just finding the average of some numbers, except this is kind of like a continuous function. So 700 x e to the, oh actually I don't know, it might look something like this. So we're trying to add up the total sales for every single day between 0 and 60, and then we're dividing that over 60 days to find the average. Okay, anyways, let's go ahead and figure out how do we calculate this. And this is going to be the integral from 0 to 60 of our sales function, 700 x e to the negative x squared plus 700 over 60 minus 0. Now we have to figure out how do we integrate this function. I think the first thing I would do is factor out that 700. Both terms have a 700. So we can factor out that constant, and we can even put that on the outside of our integral. We get 60 x e to the negative x squared plus 1 over 60. Now this piece here, this x times e to the negative x squared, that's going to be a u substitution. And we have to let u equal the negative x squared. Right? We know how to integrate e to the x, but we don't know how to integrate e to the negative x squared. So that's a good hint. Anyways, that's going to make du equal to negative 2x dx. And the x is right here, so we're going to just divide by negative 2. And you get negative 1/2 of du is equal to x dx. And then we can substitute that in. Okay, so the average value is going to become 700 on the outside times the integral of e to the u times du e to the u plus 1 of du. I don't know why I added some extra brackets there. Thought we were going to need them, but we don't, so ignore that. Sorry. Okay, now that we've done the u substitution, the integral works out pretty nicely. The integral of e to the u is just e to the u. So we get 700 e to the u plus, oh, you know what? I probably should have separated these into two integrals. I'm going to go back one little step, right? Back here. Sorry about that. Okay, so we did a u substitution on the first one. That's why I had the brackets. First one becomes e to the u times du. The second one, this 1, becomes plus the integral 0 to 60 of 1 times dx. All over 60. E to the u du, that just becomes itself, e to the u. Oh. And the integral of 1 is just x. So you get plus x. That's over 60. Then, because our original equation had no u's in it, we're just going to plug this back in here. So it's really 700 e to the negative x squared plus 700x over 60. Now I'm going to erase some stuff here at the top that we don't need anymore. Okay, so this integral, or sorry, we've already done the integral. The average value is going to be 700 e to the negative x squared plus 700x over 60. And we need to evaluate this at 0, and we need to evaluate this at 60, because this was actually a definite integral, so this should have been evaluated from 0 to 60. We just haven't done it yet, so let's just get out our calculator and do that real quick. Okay, so when we do this calculation, when you plug in 60, I got 42,000. And then when you plug in 0, you get 70 over 6, which is approximately 11.67. And then you subtract the two, 42,000 minus 11.67 should be 41,998 and 33 cents. Since this is the average sales, it's going to be dollars. So I just rounded it off to the nearest cent. And that should be the answer. Okay, so for question number 2 here, we have a demand function for a certain product is given by P equals 500 plus 1,000 over Q plus 1. Q is going to be the demand, and P is going to be the price. So we can plug in a demand, which would be like the number of units that the market is demanding, and we can find out what price should we charge based on that. Okay, now we want to know what is the average price as the demand ranges from 49 to 94. So we have a 49 to 94. Round your answer to the nearest cent. Okay. Oh, I just noticed that the answer for number 1 should be rounded to 1 decimal place, and we actually ended up doing 2. So you might want to fix that. Sorry. Okay, on this one we will be rounding to 2 decimal places. Okay, so we have P equals 500 plus 1,000 over Q plus 1. And the average value function is going to be the same. So it's going to be the integral from 49 to 94 of this whole function over 94 minus 49. So really, the main problem is how do we do the integral? I'm going to rewrite it as 2 integrals again. Okay, so the first one's going to be integral 49, 94 of just 500 plus this other integral 49, 94, and I'm going to rewrite this one as 1,000 times Q plus 1 to the negative first power. Hopefully you're familiar with your rules of negative exponents, and you'll see why this piece is equivalent to that piece. If not, just look up the rules for negative exponents and you'll see why. Basically, the negative exponent turns your answer into a fraction. So, and then 94 minus 49 is 45. Okay. So now what do we have for our average value? I'm not going to, well, actually, this piece is pretty easy to evaluate. It's 500Q. And then we'll evaluate that between 49 and 94. But we're going to do that at the end. We'll do that later. Okay, now the second piece, this requires a U substitution, and it's a pretty simple one. So you get U should just be equal to Q plus 1. That means du is equivalent to dq. And then we can write this integral as 49, 1,000 u to the negative 1 times du. Actually, I guess I didn't really need to use that negative exponent. So this u to the negative 1 is just the same thing as dividing by u. And I'm just going to leave it like that. Still over 45. Okay, the reason I left it like that is because this integral is equal to the, well, 1,000 times the natural log of u. So now we have 500q plus 1,000 ln of u, all evaluated from 49 rather, to 94, and then dividing by 45. So then we just get out our calculator and we evaluate this function, 500q plus 1,000 ln of u, at 49 and at 94. And you should get, let's see, 51,543.29 when you plug in 94. When you plug in 49, you should get 28,391.82 all over 45. So we subtract those two. Divide by 45. And that should be 514.48. 514.48. And again, this is a price, so I think it should be in dollars. And there's your answer. So basically, it comes down to this average value of a function formula, which, one more time, integral from a to b of whatever function that you have divided by b minus a. Remember, you're summing up all the parts and then you're dividing that by however many parts you have. So it's analogous to taking an average, but instead of adding up discrete items, you're adding up a function which is curved. So the formula involves an integral. Okay, so for problem number 3, I am looking up the definition of a Gini coefficient, and it's defined mathematically based on the Lorenz curve, which plots the proportion of the total income of the population that is, well, it shows what percent of the population has how much of the wealth. So what we're going to do is you start with, that wasn't great. You start with something like this, and it should look like a right triangle. This is income, and this is the cumulative percent of population who has that income. So once you get to 100% of all the income in the country, right here, that should add up to 100% of the population. So we're basically talking about a square, or a triangle with an area. This side is equal to 1, because 100%, and this side is also equal to 1. So the total area of this triangle should be 1/2. Right, base times height divided by 2. So the area of this triangle is 1/2. This diagonal line represents the line of equality, because everywhere along the curve at 50% of the total income, that should represent 50% of the population. So it's perfectly proportional. This would be the line in a theoretical country where everyone makes the same income, right? Everyone has an equal share. Then we have our Lorenz curve. And our Lorenz curve shows us what is actually going on. and it usually looks something like this with various curvatures, right? So this 50% of the population ends up with a little less than 50% of the income, so on and so forth. So this little curve, depending on its curvature, tells us how the income is distributed throughout the population. Anyways, the area of this piece, I'm just going to call it alpha, and this piece is called beta. Basically, what we're looking for the Gini coefficient is the area of the alpha piece divided by the total area of alpha plus beta, which is just a triangle, which is just 1/2. Then you might ask, how do we find the area of this curved piece? That's a great question. It's going to be an integral. The area between two curves is something like this. The integral from a to b of the top function minus the bottom function times your dx. And I think that's it. So the top function is a diagonal line, and the equation for that is y equals x. And the equation for this bottom curve is our Lorenz curve, which we've been given two different Lorenz curves. So we're going to have to do this calculation twice. So let's just go ahead and calculate the first scenario. And that's going to be y equals 0.99x to the 2.1. Y equals 0.99 times x to the 2.1. That's interesting. Okay, so then the area between that curve and the diagonal y equals x is going to be the integral from 0 to 1, because we're going from 0 to 100% of the population, so that's from x equals 0 to x equals 1 of the top function, which is x, minus the bottom function, which is 0.99x to the 2.1. Now the integral of that should be 1/2 x squared minus 0.99 times x to the 3.1, and then we divide by 3.1. Then we evaluate that at 0, and we evaluate that at 1, take the difference. Okay, after you do the calculation, you should get, when you plug in 1, you should get 0.1806. And when you plug in 0, you should just get 0. So the area of this alpha piece, or this shaded piece, for us right now, when the Lorenz curve is 0.99x to the 2.1, is 0.1806, and then we divide that by 1/2 to find the Gini coefficient, and that should be around 0.3613. Okay, so this is the Gini coefficient that is associated with this Lorenz curve here. 0.99 times x to the 2.1. Now we just need to do the same calculation with a different Lorenz curve. And the new Lorenz, well, let me erase a couple of these things. The new Lorenz curve should be y equals 0.36 x squared plus 0.64x. Okay. So then the area of the alpha piece is going to be the integral from 0 to 1 of the top function, which is y equals x, minus the bottom function, which is 0.36 x squared and 0.64x. Both of those become negative because we're subtracting the whole function. Okay, I'm noticing the x and the negative 0.64x could just make 0.36x. So we get area of the alpha piece is integral from, so I'm just combining these two. At 1x minus 0.64x is 0.36x. Okay, then we can go ahead and evaluate the integral. This should be 0.36x squared, and we divide by 2. And this should be 0.36x cubed divided by 3. And then we're going to evaluate that at 0 and at 1. And that should tell us the area of the alpha piece. Okay, when you do that, you get 0.06 when you plug in 1 and 0 when you plug in 0. So the area of the alpha piece here, the shaded piece, for this curve is just 0.06. So then the Gini coefficient is just going to be the area, 0.06, divided by the area of the whole triangle, which is 1/2. And that gives us a coefficient of 0.12. So the Gini coefficient actually went down, and that means that the income equality is more balanced. So if this black curve, maybe this one represents a 0.3613, and then the 0.12 is going to be, I'll draw in blue, it's going to be a little closer to being a perfectly flat distribution. So maybe this area here is going to be the 0.12. So that means by changing the Lorenz curve to the second function, we just equalize the income distribution by, it looks like about 24%, or 0.24 in terms of a Gini coefficient. So that's how you do that. Basically, it comes down to this area formula here, which is the area between two curves or two lines. So don't forget, it's just the top function minus the bottom function, and then you integrate that between your two boundaries, which for us were 0 and 1, because we're talking about 0% of the population and 100%. So that's just between 0 and 1. I think for a Gini coefficient, it's always going to be between 0 and 1, because you just want to add up the whole population, which is 100%. And I think that's it.